Hi everybody, my name is Konstantin Klamka and today I will present Rapid Iron-On User Interfaces. This project is joint work with Raimund Dachselt from the Interactive Media Lab Dresden and Jürgen Steimle from the HDI Lab at Saarland University. So if we look at current trends of e-textiles, we see an increasing amount of emerging applications and use cases. However, a remaining question is how technology enthusiastic makers and innovative designers could take part in this development. To address these challenges, a lot of research has been done in crafting e-textiles, developing modular wearable toolkits, investigating advanced fabrication and sensing approaches, as well as creating cuttable smart tapes. Finally, our work also builds on the idea of interactive fabrication. Inspired by the sketching-like interaction of handheld correction tape or packaging tape dispenser, we introduce rapid iron-on user interfaces, a novel fabrication technique to combine design and fabrication into a single process. Therefore, we developed a handheld ironing tool that directly transfers adhesive functional tapes and patches onto fabrics. The device uses an iron that could be pushed for bonding tapes via heat activation. The tapes itself are rolled on spools with a carrier layer. As you can see in the video, it is possible to iron on traces in a sketching-like fashion. Angles and crossings can be realized by placing and ironing a connector stencil, peeling off its protection layer, and sketching above with an inserted trace spool. We also fabricated stretchable traces, as well as shielded ones made of ultra-thin fabrics. In addition, we introduced zip-on connections as exchangeable mechanisms for multiple purposes, like detaching electronic parts before washing or changing models depending on the context. So far we have learned to manage wiring, right? But what about further input, output and computing components? With our work, we also introduced a comprehensive library of components, which are mostly realized as functional patches to be ironed on in the same manner. To demonstrate the versatility of our toolkit, we also implemented applications for ubiquitous and wearable computing, including a solar-powered smart bag with integrated lighting, a moisture sensor and music controls as the shoulder pads. Finally, we conducted technical experiments, as well as hands-on sessions and reviews with fashion, textile and fiber experts. Thank you for your attention, and if you are interested in more details and building instructions, please check out our paper and project page.